Welcome back for the very last section of Business Calculus for Spring 2020. This is section 3.6, and I know this page is full of lots of announcements, so I apologize ahead of time, but lots of things that you need to know. So first of all, just to put it in writing, I've said this a couple of times, all times when you have things that are due are Central Time, so please adjust your personal schedules to make sure you're matching these times in Central Time. So homework and quiz number 10 is only over section 3.6, and that's what I'll be covering today. It does open on Monday, April the 6th, and is due on Sunday, April the 12th at, I forgot to put the time on there, 11:59 p.m. That's when all of these are due Central Time. The Mastery Quiz for Test 3 will open on Tuesday, April the 7th. Sorry about that. Apparently I can't read a calendar. Tuesday, April the 7th. I might go ahead and open it on Monday, but we'll just kind of see. It will be due on Monday, April the 13th at, again, 11:59 p.m. So make sure you're paying attention to that. You will get the 3 attempts that you normally have gotten for the Mastery Quiz on the test. So hopefully that will help you practice and study for your test. Now, test 3. This will cover sections 3.1 all the way through 3.6. It's homework and quizzes number 7, 8, 9, and 10. I think that's correct. Yes. And it will be given during your scheduled class time. So for Tuesday, Thursday classes, it will be on Tuesday, the April the 14th. If your class meets at 8 o'clock in the morning, then your test will be at 8 o'clock that morning. For Monday, Wednesday, or Monday, Wednesday, Friday classes, your test will be on Wednesday, April the 15th. So for example, if your class is at noon on a Monday, Wednesday, Friday, your test will be at noon on Wednesday, April the 15th. You will have 60 minutes from the start of the class in order to take your test. It will be given in using MyLabs Plus, and you do have to have the lockdown browser, so please make sure that you have done your honor code statement and you've got everything set up and you're just waiting for it to open. You probably need to refresh your screen right at the time the class starts just to make sure, and then you will click on your test and you will get started. It will be a combination of multiple choice and fill in the blank questions. It will be fun. You will be well prepared from having gone through the homeworks and quizzes. As I said, you'll have 60 minutes from the time your class starts. So that means if your class starts at noon and you just kind of show up kind of lackadaisical at 12:15, you only will have 45 minutes left of your test. So please make sure that you are ready to start on time. If you've already taken your quizzes, then you'll know that the lockdown browser is working. So please make sure you've got everything set up and ready to go. All right, and Central Time. So, all right, let's get started with the very last section in Business Calculus. This is the section on what are called marginals. And we're going to talk very kind of in depth about what these are, and this is something that you will probably run across in your business courses for those of you who have not started taking those yet. So this is kind of a long explanation, but I'll try to make it make as much sense as possible. So we can use calculus to make some approximations. So I really love this example. It says, suppose that an animal rescue organization is considering increasing its monthly production of public service announcements from 12 to 13. Now, it says to estimate the resulting increase in cost, it would be reasonable to find a rate at which the cost is increasing when 12 PSAs are produced and add that cost of add that to the cost of producing the 12 PSAs. So in other words, you know the cost of producing 12, and we're going to estimate the cost of producing one more public service announcement. And that's going to give us an estimated cost of producing 13. So it's very possible that depending upon what type of organization you have, that they've never produced 13 public service announcements in a month. And so they don't know that cost. And so this would be something to kind of make that reasonable estimate. You could even do 2 times the additional cost to maybe estimate estimate the cost of producing 14 of these public service announcements. So this is something that especially like a smaller business might consider using if you're trying to kind of guess as to what's going to happen in the future. So while we might say we should just be able to plug that number in, plug in 13, well, maybe we don't really have a function to work with. So we can use this if we didn't have a function. We can use this to kind of guess what's happening. Okay, so let's see how this works. This is kind of the down and dirty. I apologize. I know this is very blurry. It's not your screen. It is just the information that we have. So it was great information, and when we tried to blow it up, it kind of fuzzed out, but it'll be fine. So C, R, and P are still our total cost, total revenue, and total profit functions from the sale of X items. We say that the marginal cost, and this is going to be true, marginal cost, marginal revenue, or marginal profit, it's going to work exactly the same way. We're just going to change the function. So the marginal cost at X, whatever X happens to be, is written by finding the derivative at X. And it is the approximate cost of producing the next item, or the X plus first item. So this is, it says C of X is the cost of producing the next item, X plus first, minus the cost of producing X. Or we can say that the cost of producing the next item, say maybe we're going from 30 to 31 items, is the cost of producing 30 items plus the approximate cost of producing the next item. So all of this to say that if we want to estimate the cost of producing, a while ago, those 13 PSAs, so if we're estimating the cost of producing 13, then we can take the cost of producing 12 and add to that the marginal cost of producing 12. Now, keeping in mind, again, this marginal cost is the approximate cost of producing the next item. So you're adding one to that without doing so. Okay, I know that's a little bit confusing, but hopefully these next couple of examples will help this a little bit. So we're going to be using this to figure this out. Okay, you got this. I promise you can come back and reread this 100 times if you want to, but you're good. All right, so we're going to walk through this step-by-step process here and make some comparisons. So we're going to start by saying, all right, we're given a revenue function of 5x. These are nice functions. We're given a cost function of 1/1000th, tenths, hundred thousandths x squared plus 1.2 or 1 2/10 x plus 60. And the first thing we want to do is to find the total profit function, recalling that the profit function is that revenue function minus our cost function. And so our total profit function is going to be 5x minus, and you know, you've already seen me do this before, I'm going to write this in with this in parentheses, and then we're going to distribute that negative sign. And if you can skip that step, then you can just scoot right on through this part of the video and check your answer at the end. So we're going to distribute this negative sign, minus 1.2x and then minus 60. So our profit function is going to be 5x minus 1.2x, or 3.8x, minus 0.001x squared minus 60. And that is our profit function. So then the next part says, let's go back and find R of 100, C of 100, and P of 100. And we're actually going to talk a little bit about what that means. So if I find R of 100, I'm literally going to plug 100 into my revenue function up here. And so I find that R of 100 is 500. Okay, and so what that is the revenue that we gain, the amount of money we take in when we produce and sell 100 items. Okay, it doesn't ask for that, but I'm just trying to get you a little bit of context here. So C of 100, we're going to take that cost function up there, making sure that we're very careful, one too many zeros there, very careful with our decimals when we plug this into the calculator. So times 100 squared plus, and I know you've got your calculators out. I wish you could just give me that answer. That would be amazing, but it's okay. So C of 100 is going to be 190. All right. So now we're going to find R of 100, or excuse me, P of 100. We found R of 100. What is this 190? It is the cost of producing 100 items. Okay. So now profit, I'm going to give you the short way to do profit. So profit, remember, is revenue minus cost. And so since we've already gone to the trouble of finding the revenue at 100 and the cost at 100, we can simply subtract 500 minus 190, and this gives us 310. So the profit realized when 100 units are produced and sold is 310. You could have also gotten that by plugging 100 in for X and 100 in for X and going through this process. You'll get exactly the same thing, but it's kind of nice to know that there's a shortcut out there. All right. So the next thing we want to do is we want to find R prime, C prime, and P prime of X. So these are actually your marginal revenue function, your marginal cost function, and your marginal profit function. So another way to say the derivative is marginal. So marginal means find the derivative. All right, so if you see find the marginal something, that's finding the derivative. So we're going to find the derivative of the revenue function. Hopefully you remember that revenue function was 5x, and so the derivative is just 5. So that's kind of nice. I like that derivative. The derivative of the cost function, if you need to pause and go back and write it, I'll flip back here real quick. There is my cost function, and the derivative of that is going to be, x squared plus, oops, not x squared, x, sorry. Should have paid more attention to that. 0.002x plus 1.2. I wrote it down, then I couldn't find it. And then the P prime, you can find actually the derivative of that profit function, or you can take the revenue function minus the cost function's derivative, and 5 minus 0.2 is 3.8, and then minus 0.002x. Either way is perfectly fine. I kind of like that little short way sometimes, okay? All right, it's kind of a nice double check. All right, so then the next thing we want to do is to find the derivative at 100, the derivative of cost at 100, derivative of profit at 100. So we're going to plug these back in. So the derivative of the revenue evaluated at 100 is just, yeah, it's just 5 because there's no x there. So what this is telling me is that revenue is actually going to increase by 5 when I produce or sell the 101st item. It's actually going to be constant. So for this particular function, our revenue is increasing constantly by $5 or whatever the units happen to be for every additional unit that we produce and sell. Okay, so because this one doesn't change at all, it's just going to become a constant 5, and it's a positive, so that revenue is going to increase, and I guess that's good. I mean, we would like our revenue to increase. All right, so C prime. And by the way, I'm answering part E here as we go through this, okay? So this means that our revenue is increasing with the production of the 101st item by $5, okay? So an increase of 5 with the sale of the 101st unit. Like I said, I kind of took it a little bit further than that. C prime of 100. So now we're going to plug 100 in for x in our derivative. And C prime of 100 turns out to be 1.4. So there will be an increase also of 1.4 units, whatever those happen to be. So in cost with the production of the 101st unit. Okay, and then finally P prime of 100, we can still go back and use 5 minus 1.4, and so that is going to give us 3.6. And once again, these are all approximate things. So we say that the profit increases by approximately 3.6 with the production and sale of the 101st unit. Okay, so this is our profit is increasing. So that's good. Our profit seems to be increasing as we move to that 101st unit. Okay, and so we've explained these as we've gone through this. I think it makes a little bit better if we explain as we go rather than backtracking. All right. Okay, so hopefully you're starting to get the hang of this. Okay, so this next one is really going to kind of walk us through how we might use this, and then whether it's a good use, a bad use, when it might be positive and when it might be negative. So the first part says we were given the daily cost in hundreds of dollars of producing X security systems, and we're given a cost function. And we are told that this company currently produces 40 security systems every day. So what is that current daily cost? So to find this, we're going to evaluate C of 40. So we're going to take our actual cost function here, and we're going to plug in 30 to this. So just kind of a plug and chug problem. There's absolutely nothing wrong with our plug and chug problems. So we do all of this into our calculator, then the cost of producing 40 is $21.24. Remember, this is in hundreds of dollars, so we say that current daily cost, because we know daily, right now they're producing 40 items, the current daily cost is $21,400 or $212,400. Okay, so the cost is in hundreds of dollars. Okay, all right, so the next part says, what is the marginal cost when X is equal to 40? All right, well, marginal is the derivative, so the first thing we need to do is to find the derivative of this function. So we're going to go back up here to this function, 0.06 x squared plus 0.2x plus 42, and then we would plug in 40. And we'll talk about what that means. So we're going to go through, we found our derivative, and now we're going to evaluate it at 40. So for those of you who think I talk too fast, you can pause me, you can slow me down, it'll work, it'll be fine. So C prime at 40 is 59.6. Okay, so this is going to be, remember what our marginal cost is, this is going to be the approximate cost of producing the 41st unit, okay? So this is, what we're saying is that it will cost approximately, because this is an estimate, approximately 59.6. I know this is in hundreds, but we're gonna stick with our decimals for right now. We'll come back to those later on. Will cost approximately 59.6 to produce 41 security systems. Okay, so that's an approximate cost of producing one more. Keep this number in mind, remember it. Write it down somewhere if you haven't written anything else down. Write this one down. Okay, so now we're going to move to the next question, which says using the result from the previous part, which was C prime of 40 is 59.6. Use this to estimate the daily cost of increasing production to 42 security systems daily. So we're going to approximate the cost. So this is an approximation. Approximate this cost by starting with the cost we had for 40, which I'll remind you of in a minute, plus, now this was for the 41st unit, so we need to do this times 2. Once again, it's not a super great estimate, but it's going to be an estimate, and that's what we need. So 2 times that estimated increase in cost. All right. So if you recall from the previous page, the cost of producing 40 units, and this is where I say we're going to go with the number we have here. We can multiply that by 100 at the end to get the actual cost. So 2124 plus, and then we're going to have 2 times 59.6, and we put all of this together, and we can even use little squigglies here or the equals with a dot over it, whichever one you want to do. So this approximate cost is going to be 2243.2, and we'll stop here. Okay, this is the approximate cost of producing 42 security systems. Okay, so if we multiply this by 100, so we can say 2243.20. So approximately $224,320. Okay, so the last part of this says what would actually be the additional cost of increasing the production to these 42 security systems. So what we need to do then is we need to figure out how much it's going to cost to produce 42 systems, and then we'll figure out what that difference is. So right now we're making that approximate jump to here, but we'll compare both of these. So the actual cost of producing 42 security systems means that I'm going to go back to my total cost function. So if you remember, our total cost function is given to us right here. So we're going to be plugging this in. So we're going to plug in 42, and we're going to plug in 42 here and 42 here, and this is going to 0.002 and then 42 cubed and plus, and then 42 squared and 42 times 42 plus 300. And this, when we plug all of this in, gives us 2229.82, which means that if we multiply that by 100, we're going to have 222,982. So that's the actual cost of producing 42. All right. If we want the difference, so this says what would the actual additional cost of increasing production to 42 systems. So we would do C of 42 minus C of 40. We have all of that information, and see, it's actually less. We did an overestimate, but that's okay. So I mean, that's what happens sometimes. So the actual difference, so we have 2229.82 minus 22, oops, I'm sorry, wrong numbers there. This is the cost of producing 40. The cost of producing 40 is 2124, and so this actual cost here is $105 and well, it's hundreds, 105.82. That's the actual additional cost, which is, like I said, this is an overestimate. Sometimes it's an overestimate, sometimes it's an underestimate. So we would say that the actual difference in cost is $10,582. This is the actual additional cost to produce 42 units. All right. So lots of questions that can be answered here. So you got this. All right. So let's look at a couple of kind of strange problems here. This is actually a supply function. So it is the supply S of a new roller ball pen is given by this function where P is actually the price in dollars. So my function S is 0.007 P cubed minus 0.5 P squared minus 150 P. So the first question says find the rate of change of quantity, that's supply, with respect to price. What is this? The rate of change is the derivative. So just writing it a little bit different, this is the same thing as saying find S prime of P. So the rate of change is still the derivative. This is nothing new. We have been talking about this since the very beginning and we started talking about derivatives. So to find the derivative here, 0.21 P squared minus, once again, this is 1/2, 0.5, so I'm going to end up with minus P, and then plus 150. So this is the rate of change with respect to price. That is it. Now, the next question says, how many units will producers want to supply when the price is $25 per unit? This says nothing about a rate of change. It says nothing about anything having to do with the derivative. Simply wants us to find out when the price is 25. So when P is equal to 25, what is S? So we are trying to find the quantity that's needed to supply when the price is $25. So we're going to go back to that original function, and we have 25 cubed and then minus 0.5 or 1/2 times 25 squared, and then 150 times 25. And when we plug all of this into the calculator, we get a lovely value of 3546.9. But since we're talking about an actual item here, we're going to go ahead and round this up to a whole number. So approximately, we think that producers will want to supply 3,547 pens when they are $25 per pen. Now, this is a fabulous pen. It does all kinds of wonderful things for you. It might have even gone to the moon. It might be a space pen at $25. It should actually be thinking for you, right? So anyway, I'm not going to spend $25 on a pen, but you never know. Somebody might. So if the price per pen was $25, then the producers will want to supply, based on this formula, 3,547 pens. That's pretty interesting. All right, so let's see what else we can do with this. We may have to come back to this. So the next part says find the rate of change at P is equal to 25 and interpret this. So the rate of change means I'm going to use the derivative, and so what this means is that, and I can write this as S prime of 25. We used the other notation a while ago and that's okay, but if you recall, our derivative was 0.021 times x squared, so 25 squared minus x and then plus 150. And so when I plug all of this in, I'm going to get 138.13. And so what this is telling us to interpret our results is that when the price increases by $1, or hopefully it's dollars, when the price increases by 1 unit, then the supply needs to increase by approximately 138. That's a little bit crazy to think that as the price increases, the supply needs to increase. But maybe it's not increasing as much as it has in the past, but that's what we're going to say. So that as the price increases to $26 per pen, the supply should increase by approximately another 138 units, or pens in this case. Okay. Do you expect this derivative to be positive or negative? Well, to me, it would kind of make more sense if it was decreasing as the price increased, but, you know, Who knows? It might be that as time moves on, they would probably get to a point where it was no longer cost effective to increase the price. Maybe sometimes people tend to buy things that are more expensive because they think it's like got to be better. So, but a pen, really? I don't know. So I would probably expect this to be negative. And that's because I would expect that the supply or the demand would decrease as the price increased, but apparently not in this particular function. So sometimes we don't always get what we expect. Okay. All right. So we have a couple of more problems. So this one is the average cost for Turtlehead Incorporated to produce X units of their thermal outerwear is given by, notice this is a C bar, so our average cost. This actually tells me that my cost function, hopefully you're going to get this, should be, yes, it should be 13x plus 100. All right, so we're given the average cost function, but I kind of like you to be able to take the cost function and find this just in case. All right, so we're given the average cost function. This problem says use the derivative or the marginal average cost to estimate the change in the average cost as production goes from 100 to 101 units. So the first thing we have to do is we have to find the derivative of the average cost function. Now this is a quotient problem. We can rewrite it as a product rule problem. I'm going to go with the quotient rule. The quotient rule, we're going to use the low D high, or the bottom times the derivative of the top. I like to go ahead and put that x squared in the denominator because my quotient rule says the denominator squared. So low D high, so the bottom times the derivative of the top, the derivative of that numerator is 13, minus, don't forget in the quotient rule we have minus, and then we have the top function times the derivative of the bottom function, which is going to be 1. If I clean this up very nicely, it is going to be nice. 13x minus 13x minus 100. Then all of this is over x squared. So I find that my derivative of the average cost function is negative 100 over x squared. Now, the second part of this says to estimate the change in the average cost as production goes from 100 to 101 units. What tells us what that change is? Yes, we plug in the 100 because that's going to give us the estimated cost of the next unit. So to answer the question, then we need to find C bar prime of 100, and this is going to be negative 100 over 100 squared. You might be looking at that and going, hey, the change in cost is negative. It is. So that's actually pretty significant. So this simplifies to 1 cent. And it's negative. And so what is that telling us is that as production goes from 100 to 101 units, the cost is decreasing by 1 cent. So as production goes from 100 to 101 units, the cost, the average cost, sorry, I forgot that word, the average cost decreases by approximately 1 cent. Okay, so now we're starting to see some applications of these. All right. Now, just to remind you, yeah, these guys are coming back. So we have a couple of application problems having to do with derivatives of exponentials. So the derivative of e to the x, remember, is just e to the x, okay? And the derivative of e to the f of x is the derivative of that exponent times e to the f of x. And I'll remind you as we get to those, all right? So real quick, I'll just give you a problem here. Let's say if I give you y is equal to, that should say y rather than f of x. Sorry, I kind of messed up this notation. Let's say y is equal to e to the negative 3x, okay? Then the derivative of this would be the derivative of this exponent, which is negative 3, and then times e to the negative 3x. All right, so now we've got a quick review example. Okay, so this problem says the total cost in millions of dollars for Marcotte Industries is given by c of x is equal to 200 minus 40 times e to the negative x, where x is the time in years since the startup date. Find the marginal cost, and what does this mean? Okay, so find the derivative. Marginal cost is the derivative. So the derivative of this function, well, the derivative of 200 is 0. The derivative of negative 40e to the negative x is going to be negative 40 times the derivative of negative x, which is negative 1, and then e to the negative x. So the derivative, or the marginal cost function, is 40e to the negative x. That is my marginal cost function. Now, if you recall what this graph looks like, this particular graph, this is it's positive, but it is decreasing because of this negative x. And so what this means is that the change, the marginal, remember the marginal is the change. This means that the change in cost is actually going down, okay? Because these values will, it's not going to actually have a negative value, but it is going to be changing, okay? So this is indicating to us what the change in cost is doing, and the change in cost is actually going to be decreasing, and it's actually going to be kind of leveling off here, all right? We're going to find that out. So the next part of this says to find what c prime of 1 is. So we're going to take 1 and we're going to plug it in, and we're going to actually see what's happening here. So e to the negative first power and times 40, and if I plug this into the calculator, I'm going to get 14.72. That's rounded to a couple of decimal places, right? The second part of this, I really want you to kind of see this at the same time, is now e to the negative fifth times 40, and this is going to be a much smaller number, 0.2695. What is happening to these changes as we move along from the startup date? The cost of production for this particular company is getting closer and closer to 0, and so the change is getting close, the change in cost is getting closer and closer to 0. So basically cost is kind of leveling out, sort of, and so that's what we're really trying to see what's happening here. So my change is getting closer and closer to 0 as I increase number of years. That change in cost is getting closer to 0, and we're actually going to see that with the graph on the next slide. So this is the graph. Once again, it's a little bit blurry, I apologize. This is actually what 200 minus 40e to the negative x, this is what the graph looks like. And so just to kind of emphasize what's happening to you and remind you about how to look at a graph and talking about limits to infinity, as my x values get larger and larger and larger, and this is my x-axis, notice what this cost is doing. Do you remember the limits as x goes to infinity of e to this? Yes, this is your horizontal asymptote. Yes, it is. That's exactly what an x goes to infinity is. This is, we're looking for our horizontal asymptote. And this value is 200. And so what's happening to my actual function is that cost is kind of leveling out, okay? The change in cost is getting close to 0, and so that cost, the cost of producing 0 units is still $200. If I put 0 in here, or it's actually going to be 200 minus 40, so 160. So my cost is actually leveling out here. So the limit as x gets close to infinity of this function is 200, right? I know this section has been kind of a lot of material and a little bit strange and different material, but guys, we are done. This is all of the content for this course. Go do your homework, take your quiz, make sure you're ready for it, do your mastery quiz. Do it the first time without your notes. Do it the second time with your notes. Ask questions. Email your instructor. Join in on a WebEx session that some of them are doing and or that I'm doing, and ask your questions. Get ready for that test, and you're going to be great. Don't forget to show up at your class time. Actually, probably I would show up, log in a little bit before your class time, show up online, not in class, show up online a little before your actual class time so that you are super ready to take that test. And then we'll talk a little bit more about the final exam. We may post a review for the final exam. There will be a mastery quiz on My Labs Plus for that final exam, and we'll be giving you some more information about that. So good luck. I hope everything is going well and that you're doing your weekly check-in quizzes just to let us know what you're learning and how everything's going. Reach out to us through email, and hopefully we've got this. So take care and bye.